Hello students, so today we're looking at chapter 8I on tree diagrams. This is an alternative to using the tables to map out a sample space of a multi-event experiment or test or survey, whatever it is. So just to go over the words here, we can use a tree to map out the possible outcomes, the sample space. And we want to be able to use the tree diagram to map out probabilities of events in multi-step experiments. I think the limitation of the table method is that a table is really two-dimensional. So here is my first event, rolling a dice, and then I would choose to roll a coin. And where these two things converge, I would get a map for that possible outcome in the sample space. However, if I had a third event, so 1, 2, where would my third one go? So I think this table would become like a three-dimensional table at that point. So I think that's probably why the tree diagram may have been introduced as an alternative that doesn't require three-dimensional tables. So that's all just written here is that we used a table in the past, and hopefully you can figure this out. So on a dice, I could roll a 1, which is over here. And if I flip a coin and I get a head, then there's a result of getting a heads and rolling a 1. I could also roll a 4, which is this result. And then I could flip a coin and get a tail. So combine these two together. That's one of the possible combinations we could get. I could flip a tails and I could roll a 4. Just introducing the tree diagram. So I want you to imagine this is our first event. So for example, it could be our dice roll. And then this is our second event that follows immediately afterwards, which could be our coin toss, for example. Okay, so I've just written this little bit here in green. You don't need these bits of green, but I think that helps you figure it out. So guess what? If there was a third coin toss, then we would have that written here, and we would have more heads and tails drawn in here. I'll draw it in step by step in a moment, but we can just sort of see how this is all going together. So I guess we can hear it. I'm supposed to switch to green. I guess this is our starting point. So if I have a first coin, I can get a heads. If I flip a coin again, I could get a heads or a tail. So if I get a tail, then for these two coins, I could get one that has a heads, one that has a tail. That's how it maps out. Alternatively, I could start here and get another heads, but also another heads, and that leads me to this result here of 2 heads. Okay, so this column here is the outcomes, the sample space, the finished result I guess we're looking for. And perhaps another way of viewing it is that this area here is our working out to figure out what the sample space is going to be. You know, with the first coin, I could get a tail, and then my second coin, I could get a head, therefore tails, heads. I think the book is really particular with when I write this, you got to write this first event first, and my second event second. So you might notice that these two events are quite similar, but they're back to front. And that is because of the way the results appeared. So perhaps that's an important detail. So the first event was a heads, and then the second event was a tails. All right, I'm going to backspace this, and we're going to move on. So let's try to map out our own tree diagram. So this one here, it looks like the textbook likes to use you draw some letters from this word, and then you draw letters from another word, and what are the possible combinations? It's a really strange one, so I'm going to use that as my example here rather than just doing more coin tosses or a dice roll, because I think those are quite intuitive. But the word ones, I don't know, they seem a bit more strange. So let's read this one out. So it says, from the letter word on, which I've already done here for us, is chosen, and then, oops, I spelled that one wrong. Then a letter from the word for is chosen. So I need to figure out my second letter from there. Map out the possible outcomes using a tree diagram. So I've already mapped out from the first letter, from the first word, which was on. My second letter will come from my second word, which is the word for. This one. So I could draw the letter O, and then I could get an F, an O, or an R as a possible outcome, and possible result, and therefore my outcome would be O then F, so that would give me OF. My next one will be OO. I'm not going to circle them anymore. It's just going to be cleaner on the screen here. Last one here is OR. Likewise, if I drew the letter N, I will get some new results. So I could get it. My second letter FOR. Again, that's from the second word that's been chosen from. So I will get NF, NO, NR. That's our map. This will be our sample space. I think I've put some questions to go with it. How many outcomes have two consonants? A consonant is the opposite of a vowel, so it doesn't have I, E, O, U. So two consonants that are N and F don't have a vowel. These ones all have vowels in them, so that was not an answer. N, O, N, R. I think this is another one. So we have two, oops, that's supposed to be a pen stroke there. Two outcomes. And if I really wanted to, I could actually write what they specifically are. Next one here. How many equally likely outcomes are there in total? Equally likely. Yeah, that was a weird question, so I'm not entirely sure what it was looking for. I was hoping that once I mapped it out, it would make sense to me. How many equally likely outcomes are there? I guess what we're probably looking for are these combinations. Are there any that are the same as each other? Are there duplicates, for example? If there are duplicates, then they're going to be more likely to occur. If there's no duplicates, which I think this is the case what we have here, they don't have anything that they have in common. So I would say 1, 2, 3, 4, 5, 6. 6 equally likely outcomes. I think if I choose a different, my next example, maybe there would be a few outcomes that are basically the same thing as each other. For example, with these heads and tails, ones that are equally likely to appear would be these ones, okay, because they're basically the same as each other. And these also would be equally likely to occur from a probability standpoint. Okay, I've chosen a little bit of a harder question. This is from problem-solving questions, rather than just doing more basic coins or a spinner with 3 items on it, for example. I want to go something a bit more interesting so that you see a variety of solutions, so you're more confident trying them yourself. Okay, 2 letters are chosen from the word car. Once a letter is chosen, it cannot be chosen again. So that sounds like I got 2 events. All right, so I've got letter 1, and then letter 2, and then I'll have an outcome for the combination. That 2 letters corresponds to my 2 letter pickings or 2 events. So since it's from the word car, and the first question says draw a tree diagram. So I would have C-A-R as my 3 possibles for the first letter. Then for my second letter drawing, I would have C-A-R. However, the question says, once a letter is chosen, it can't be chosen again. So I guess we can't have this combination. So I can simplify this out. So there would be that. And got those 2. So that combination there would give me C-A, because the C came first. Then I would have C-R. Likewise with here, I've got the letter A. I'll have 2 outcomes here. So I can't pick the letter A again, but I can have the letter C from car. I can have the letter R, so that'll give me A-C-A-R. And this one will also have 2 combinations. So we can have the letter C, we can have the letter A, but we can't have the letter R a second time. So we look at this one, we got R-C, R-A. Just curious around here, do we have any that are duplicates of each other, like maybe back to front. Let's see, RA, do I have another RA in here? I do, so these ones here are duplicates. They're just back to front. RC, looks like those are duplicates. And I presume these ones are also duplicates back to front. Let's see what the next question asks us to do. What is the possibility that A and C will be chosen? So A and C would be these two together. So out of our, there are 6 outcomes in total, and 2 of them have an A and a C. So we've got 2 out of 6 outcomes. I should probably do this properly, so formatting reasons, it should be probability of A plus the C would be 2 out of 6, which simplifies to 1 over 3. We should always have our answer as simple as possible. Next question here, find the probability of getting 2 consonants. These are the non-vowels. So if we look at those, this has no vowels, this has no vowels, and all the others have the letter A, so that would be also 1/3. So this would be equal to 2 out of 6 results, which is 1/3. Find the probability of having 2 vowels. That'll be the others, 1, 2, hang on. 1, 2, 3, 4 out of 6. So that would be 4 out of 6 outcomes, which simplifies to 2/3. Simplify always. And lastly, probability that the letters chosen will be different. Tricky one. I presume that the ordering of the letters won't matter. If they do matter, then we'll have 6 completely unique outcomes. But if they don't matter, that's not really an interesting answer. So I'm thinking that the order of the letters that have been drawn is not important in this question. So we would have, well, we got these, well, that's supposed to be the pen stroke here. These two are the same, these two are the same, these two are the same. So we've got 3 combinations. So I think it's going to be 3 pairs. I'm curious to see if it's supposed to be, the answer is also 1/3 chance that you would get different letter combinations. The letters chosen will be different. This one's a strange one because are they referring to this choice and this choice giving where they're different from each other? If that's the case, then they're all going to be different. So there's a 1 out of 1 chance that any drawing you get, these letter combinations, each one of them won't have duplicate letters. Are they saying that the outcomes are different? I'm not sure. I'm going to check the answer, what they're expecting here. So E. Yeah, okay. So they went with the answer equal to 1. So probability they are different letters is 1 out of basically six outcomes out of 6. That's probably what that meant. So if I draw a letter from here and draw a letter from here, are they different to each other? And they are all different. So we have probability is 6 out of 6, which gives us the 1. So a bit of a strange question there. I did have to scratch my head for a while doing that. Look, that's the end of my video. I think you've got enough to get going and draw them for yourself.